So we've looked at polynomials that when we factor them, we actually get more than two factors. And what that also will do is when we're working with an equation that ends up with that polynomial as one of its expressions, we could end up with more than two solutions. So let's take a look at two examples here. I have 7a cubed equals 175a. So remember, the first thing we're going to do when we're solving an equation that has more than one solution here is I'm going to set it equal to 0. I'm going to use my zero product property to help us solve this. So we're going to set this equal to 0. So I have 7a cubed minus 175a. When we started talking about polynomials, we started talking about the degree of the polynomial. And the degree will give you an idea of how many possible solutions there are for this particular equation. So the degree here is 3. So I could end up with 3 solutions. Now there may only be 2 or 1 or no solutions at all, but I want to be on the lookout for I might get 3 discrete solutions, 3 separate solutions for this. So I'm going to take this, I'm going to factor this polynomial that I've isolated on the left-hand side of here away from the 0. I'm going to look for a greatest common factor, and I can take 7a out of both of these, so I'm left with a squared minus 25. A squared minus 25 is the difference of squares, so I'm going to break that down into a plus 5 times a minus 5, and I can't factor that anymore. So I've ended up with 3 factors. I'm going to set each one equal to 0, and I end up with a equals 0 as one solution, a equals negative 5 as a second solution, and a equals positive 5 as a third solution. So I actually do have 3 solutions here, negative 5, 0, and positive 5. Let's do one more. 48n cubed equals 147. So again, I want to get the 0 on one side, put everything to one side so I can use my zero product property. I'm going to start to factor this. I can take a 3n out of each of these terms. That leaves me with 16n squared minus 49. So I break that down because this is a difference of squares. So 16n squared, square root is 4n, 49, square root is 7. Make one addition, one subtraction. So I end up with 3n times 4n minus 7 times 4n plus 7. I'm going to break those each up and set them each equal to 0. So 3n could equal 0, which means n equals 0. 4n plus 7 could be equal to 0, which means that n could be equal to negative 7 fourths. And 4n minus 7 could be equal to 0, which means that n could be equal to 7 fourths. So that leaves me with 3 possible solutions again. Notice we had a degree of 3 here. So I have negative 7 fourths, 0, and 7 fourths as 3 possible solutions for this equation.